point B, and then click the line itself, and I have a nice perpendicular line that goes perpendicular through point B to this line here. And the reason I'm going to do that is because I want to actually build a right triangle here. So the next thing I'm going to do is I'm going to click on my point tool. I'm going to go over to that perpendicular line that I just created and put a point on that line, and then put another point here on this line. Okay? So there we go. So I have a point D here, I have a point C, and I have a point B, and I'm going to build a right triangle through those 3 points. To do that, I'm going to click on the polygon tool, which is this tool right here, and just click these points. So D, B, C, and then back to D, and I have just built a beautiful right triangle. Okay? We can see that right here. So if I move this point around, you can see there's my right triangle. Now, I got some stuff here that I don't really want. I don't really need this line here that I created initially, or this line that I created perpendicular. So in order to kind of hide those lines, I'm just going to go up, and I'm on my arrow tool here, and I'm going to right click on that line, and where it says show object, I'm going to select that, and that more or less hides that line there. Okay? I'm going to do the same thing with this one. Right click on that line, uncheck where it says show object, and now I don't see that line anymore. And I have to do that one more time with this point A. Right click on there, come on, right click and show object, get rid of that, and this is what I want to see. I just want to see a right triangle that looks like this. Okay? And you can see, you know, that right angle is maintained right here, and I have a beautiful right triangle. Okay? Now, the next thing I want to do is create some segments that go from all 3 of these points. So I'm going to go up to this line tool, labeled, and I know what the length of all 3 of these segments are. Now I'm going to create squares that go off of all 3 sides of this triangle. All right? So how's that going to work? If I go over to this polygon tool, down click on this and select regular polygon, watch how I do this. Click on D, click on C, and it's asking me on my regular polygon how many vertices do I want. Well, I'm making a square, and a square has 4 vertices, so 4 looks good. I'm going to say OK to that, and check it out. There's a square that I've created using DC as the side of the square. Okay? I'm going to do that 2 more times with the other 2 sides of the triangle. All right? So I still have this selection highlighted. I'm going to click on C and click on B. I want 4 vertices, so I click OK, and there's my square that comes off of that side. And I'll do this one more time. Click on D, click on B, 4 vertices, click OK, and notice what's happened on this one. It's made the square, but it's put it in the wrong place. I don't like where that square is showing, so if I go up here and undo that, then I'm going to redo that square, but instead of clicking point D first and point B, I'm going to click B, D, 4, OK, and that looks much, much better. Okay? Now, back on the arrow tool, and let me show you guys that these squares that I built are right attached to all three sides of my triangle. And there's the area of that polygon, 18.42. I'm going to do the same thing with this one, this square over here. Click it. There's the area of that square. And finally, lastly, there's the area of that one. Okay? One more time on the arrow tool, notice that those areas change as the squares get bigger or smaller, corresponding to the legs and the hypotenuse of that triangle. Okay? All right. Now, how is this proving the Pythagorean theorem? Well, the area of each one of these squares is basically the side of the triangle squared. If you take this side, which is 3.22, and multiply it times itself, 3.22 squared, you'll get this area. If you take this leg, which has a length of 2.96, and if you square that, you'll get 18.76. Same thing over here with the hypotenuse of the triangle, square it, and you get this. Okay? So basically, these squares that we see are the legs squared and the hypotenuse squared. A squared plus B squared equals C squared. Okay? So I'm going to do one last thing to prove this little Pythagorean theorem sketch. So to do that, I'm going to go P-O-L-Y, poly 4, that's this square right here, plus poly 3, enter. And it's created a number, and I can see this number, which is 19.11, sitting right up here. And guess what? That number is exactly the same as the area of this square right here that we see. Okay? And if I sides of that initial right triangle, okay, notice that this number matches this area number. So that's, again, this number's plus this, which is the side squared, plus the other side squared equals the hypotenuse squared, and there you go. That looks like the Pythagorean theorem to me. Okay? So I hope this makes sense. I will talk about this a little bit more in class, but this is a basic idea about how to create a GeoGebra that shows the Pythagorean theorem. And that's it. So good luck with creating this, and I'll see you guys in class.